We are back for part 3, our Icom 706 PLL repair. And welcome to TRX Bench. Yeah, it has really taken a while, but now here I have our new reference loop PLL IC. So we want to replace this IC today, and let us see if we then can back here our PLL circuit live. So you may remember we have replaced in part 2 here our DDS IC, and this circuit is already back working, and now we're gonna replace here our new PLL EIC original Icom type, of course. Yeah, step first will be to take this IC off, and then we will replace here our faulty IC with the new one we have just received. But before we go ahead here with desoldering here our old and faulty IC, I just want to apply here some Kapton tape just to be able to protect here our circuits around and the plastic we have here everywhere. So that will be a first step. I will cover it a little bit with Kapton to make it more safe for our hot air. Okay, so now it is covered all around, and we can start applying hot air and trying to get this IC off without damaging the pads, because that is really crucial that we really do not damage anything here on the board. So therefore we will really do it very carefully. Okay, and when we look down here to our IC, you see that we have a much smaller pitch here on the pins than it was with the DDS IC. So it is even more challenging to get this IC off here, our PCB, without destroying the little pads underneath. And therefore we start with heating the PCB in advance, that we get up the temperature around the IC on a certain level, and then we can finally start lifting up the IC. Okay, and you have already here a better view onto our board than me, because I'm working around the camera a little bit, which makes it more challenging. Okay, so hot air has reached his working temperature, and I'm not down at the board, so I'm still trying to heat it up, as already said. And yeah, so this will take a little while, and then I really can go deeper. Okay. And I see here and there that it already starts melting a bit, but I'm finally not deep enough. But you may hear it from the airstream that I'm getting closer. There's really a lot of ground plane involved, and that makes it not easy to get an IC like this here off the board. And as I said, I really want to do it carefully. It does not make sense to try to make it quick, because you may really destroy more than you would love. Okay, it is really still not coming off. Yeah, and I've added a bit of flux to make it easier for the solder to flow. I mean, this is still, or what it is not still, it is unleaded solder, of course, and we know that unleaded solder has a higher melting temperature, so thus it is more difficult to get it off. And yeah, you see, it is a bit of a challenge to get it off, as you can here easily see. And also I see that it is melting. We still cannot get the IC off. But now it looks like that it becomes loose, but we still have to be very carefully. Yeah, something is happening here. Very good. And here it is. Very good. That is really very good. Yeah, you have seen that it was really challenging. I had increased the temperature to 420 degrees because with my normal temperature, which is 390, it was not working. And yeah, you see really that it is challenging, but it looks like that we did not destroy any here of our pins, so it really looks nice, very good. And now I let cool it down a little bit, and then I will clean the pins, and yeah, then we can go ahead with replacing the new IC into our or onto our PCB. Yeah, and before I clean the pads, I just apply a little bit flux here, that it is a bit easier to get it here all clean, so that helps a little bit, because we need here our pads flat and clean, that we can place the new IC, so that is very important right now. Yeah, and that is the old known process, so we really need to go down here to our board, and now we clean it here step by step, and of course with the right passion we should have, and then we work slowly around that it is finally how we need it. I mean, that is nothing special. It is basically a very easy process we have to perform here, so therefore, yeah, no secret and nothing really exciting. So let me work around, and when I'm ready I will be back for the next step. Alright? Okay, I believe so far it looks quite good, and of course now we need to clean it here, but you can see that all pads are there, so we do not lose a pad, which is very good, because otherwise it is always a pain if you are losing pads, but here it is very good, no problem at all. And you see it looks quite flat, so we obviously were really able to remove all the old solders, so that is gone. And yeah, I believe we can really place our new IC, tuck it, and then finally solder it in. Alright, time to get our new IC here out of the foil. And I mean, you have already seen these mini pins, and yeah, it is always a challenge to really do not destroy or bend. So even if you bend these pins, it is really no fun, as if you do so, you really are in trouble to get it onto the PCB. So that is really an important step. And I mean, you see that you really can easily bend the pins. And I hope that everything is still fine, because already when we got it by mail, that is already a problem, and yeah, therefore you see, I'm really not happy. Okay, but so far so far it seems to be okay. And of course we have to line it, and we have to tuck it here down, and then we can solder it. Right. Yeah, very important is to really watch out for the orientation. And you see we have the dot down here, alright, and we see here our mark on the PCB, and of course that has to line up, and yeah, so therefore it really does not make any sense to rush here, because once you have bent the legs you are in trouble, believe me. Okay, so let me rearrange here the camera, because I'm behind the camera and I'm really not able to go down here to the PCB as I need to do it. And yeah, let me reposition it, and then we can go ahead. Okay, so what you can see right now is that the IC is aligned pretty well, and now first step is of course to tuck it down, and then we go ahead with soldering. So our chip is tucked down at 2 points down there and down here. So now it is more or less here fixed in position, and I now can go and drag soldering here our chip. And as you may see, I have now a higher resolution, magnification, and flux is already on our pins, and yeah, now I have to drag solder it around. Okay, so our first 25 pins are ready, so we have here a 100 pin pack, and yeah, really the challenge here is to get here along this capacitors. I had to take out this one, and of course I have to replace this capacitor afterwards, because I really was not able to get here along. So the space here is really very limited, and that is a challenge. It is not the soldering itself, it is really the very limited space. And when you watch all the training videos and you see there is so much space between the IC pins and the components which are connected to the IC, then that is really a joke, because in real life you have a very high component density, which makes soldering very much more challenging, as it is shown in all these nice training videos. Okay, and I've cleaned it here just a little bit. It is not completely done, because I will do it completely when I have done all pins around. But just one tip I wanted to show you. Let me see if you can see it. I believe yes. So even if you work under a microscope, you cannot always be 100% sure that the pin is really connected to the PCB. And therefore, if you go over the pins like so, you would directly see if one pin is not soldered down to the board. So this little trick really avoids a lot of afterwards troubleshooting, because if we go over it like this, you really can be sure that everything is fine. Okay, and finally I have here to put back the little capacitor, and then we are ready with our first 25 pins. Yeah, and just to explain it a little bit more, when I say here the density is so high, so normally I need to go here along, okay, but I would like to be here in front of our pads and drag it along here like so. Let me see, can you see it? Yeah. So here is no, here on the rest there is no capacitor in our way, and here I'm able to drag along as we need it, okay, but here I'm not able to really go down to our PCB, because even this is really a very, very tiny tip which is here on my soldering iron, so that is really a micro pencil. But you see, even with this micro pencil, I do not have enough space to drag here along. And yeah, so normally, or not normally, I could take all these capacitors off, but to be honest, I do not like it. So I do it here very carefully, very slowly, just to be able to do it without removing our caps. And of course we do here exactly the same. We go along to be sure that all pins are really soldered to our PCB. As I said, that is very, very important. Okay, so here we have a finding. I hope you can see it. I mean, even if you don't see it, you feel it. Yeah, this one, you can see it. Even if you don't see it, yeah, you can feel it when you go over it with the tweezers. And this one here, so this is definitely not soldered here to our PCB, and therefore, of course, we need to do it once again. Okay, and we really need only a little bit of solder, so not too much. So, and then we go down again. Let's see. So, as I always say, it does not make any sense to do it in rush. So you really need to do it with patience, right? And then you will be successful, of course. Here we have another problem. So you see that my flux is mixing up here with the factory used flux, so that is the reason why it is getting here so brown. In factory they have used rosin or rosin, how do you call it, flux, and I'm using here a no clean flux, and now this both flux and here we have another one which is not really tucked down, and this of course we have to do it as well. And yeah, when you consider how small the contacts and here these little pins, you may have an idea on how small the soldering tip is. And there is another one. So that is really due to the fact that we here are dealing with a situation which is not so nice. You see, I'm already touching again here the capacitor. Yeah, I know I could take them out, but as I said, I don't want to. Okay, so that's it. Okay, so still a little cleaning to do, and then we are ready. So the IC is in, and yeah, as you can see here and there, there is still a little bit flux here on the board. Also it is a no clean flux, but as I said before, it mixed up a little bit with the factory used rosin or rosin flux. So okay, not too bad. So yeah, let me clean it just a little bit to get it a bit more tiny, and then finally we are ready with replacing the new PLL, main PLL, with DDS portion back into our circuit. And of course here our little cap is back. Just put it back onto the board, and as you can see, everything is fine. There is still a little bit rosin residue here on our cap. You can see it here a little bit, but you know, that doesn't really matter. So I mean, that does not make any to our circuit. Everything else is simply fine. And yeah, you see our solder points are nice and shiny compared here to the original reflow, which you can see here, for instance. Can you see it? Yeah, a little bit. So that is not shiny. That is most likely due to the used lead-free solder, but we have nice and shiny solder points, so that is what we really want to see. And oh, what's going on here with our little coil? So that seems to be a little bit out of place. Yeah, I should readjust it a little bit. I mean, it would work, I believe. or is it this kind of coils, chokes or whatever which get damaged when you heat it up? Maybe a risk. I better... Nah, I have to do it because it is here. It might have contact here to a ground, which is not a good idea. Yeah, let's see if we can easily move it or if it is more a disaster. So let's see. Okay, so yeah, much better. So now it should not make any short, I hope. Let's see. I know, I think it is fine. We should not touch it too much, otherwise this plastic here melts, so that is not a very good quality. Okay, so we are ready so far, and we can now definitely go ahead. I mean, everything looks pretty nice, and yeah, let's go ahead with our repair here. Okay, and before we go ahead, we do what we always do. So we check for short on our supply line. So therefore I connect here my ground to ground, and here is my probe, and of course if I go to ground I have my beep, which is telling me I have continuity. So what we know so far is that my ground is gone. Okay, so I can put here my ground clip to the wire as well, to the quarks cable here, so that is the same effect, and you see I have continuity to ground. Okay, and what we know is that here our voltage regulator is here our supply line for our DDS and for our ref loop IC. So let's check. Yeah, that is ground, of course, no problem whatsoever, and this here is plus. What? Oh, that is really not a good sign. So that is output, that is input, that is output. So that means our 5-volt line is obviously shorted. That is not fine. So let me see, this is our DDS, so this is here our little filter, short to ground, short to ground. And you may remember, this is here our filter for our ref loop PLL, short to ground. Yeah, so that is really something unwanted, really. So that is definitely a real bad sign, because yeah, so we have here definitely a problem on our 5-volt supply line, and yeah, that is no fun. Okay, and that you know what I'm talking about. So we have here our 3 ICs, DDS ICs, which we have swapped first, and here our ref loop PLL, which we swapped second, and this is here our main loop PLL. And down here, can't see it really, so how can you? So let me zoom in here a little bit. Yeah, so you see here, down here, this is our 5-volt regulator, and we tested here on the output side, and you see this is our 5-volt for supplying. So let me go up here, supplying all of our ICs. So you may see it here, 5-volt goes here over our little choke and is supplying our IC. And secondly, we have here over this little filter also supplying our DDS IC, and of course on the same line, so you can see it here, our main loop PLL is also on that line. So that means the problem can be anywhere, but well, the logical approach is, because we swapped out the IC-101 last, so we should start really in that area, and therefore I believe it is a good idea to take this little filter out, because we really don't know where the short is. As I said, it really can be anywhere, and therefore let me take this inductor out, and then we might get a better overview. Yeah, okay, on the board our orientation, so that is this inductor here, and yeah, let us take the inductor out, and let's see what we have then. Alright, so let's go down here to our filter, and here it is already. It is out, and yeah, now let's check for short. Okay, so ground is still there, so you can hear the beep. And let me go down here to the regulator and test it. Okay, short is gone. Yeah, so that is really, yeah, this is really the most worst case you ever can have after an IC replacement. I mean, now it is more or less clear that it is here really in the area of our new IC. So let me test here at, maybe I can go a bit closer that you see it maybe better. Yeah, let me check here. So that is in direction of the voltage regulator, and you see no short. But then the other side direction I see means, yeah, full short. That is really a full short. And yeah, as I said, that is really a nightmare which happens from time to time. It happens not very often, but from time to time that is exactly what can happen, and therefore it is interesting to let you know, or important to let you know, that exactly that can happen. So that means we have 3 different options. So maybe our IC itself is gone faulty again, or we have here this little caps. So maybe that one of these little caps is shorted, so that is another option. Or the third option, and that is then definitely, yeah, really, so that would be the end of the story if there is a short inside our PCB, because as we discussed it earlier, it is a more layer board, so it is not only here component side and foil side. Okay, so we have layers inside, and if we have a layer inside, then game over. Then really game over. Okay, but once again, let's have a look on our schematic that we know what we are doing. So we have taken here our little filter coil out, and what we have is here our IC-101, and if we follow here our plus line, I mean of course behind our filter, so you see it is really here going around our IC, and what you see is that we have all these little filter caps here, which are going to ground, and it happens that these caps are going short, and that could be the case, but as I said, it also can be here our IC failing once again. But let me check if there is anything else connected here to our IC-101, but when you look here around, you see it is really, so this is a loop which is going here around our IC, and it is only the IC and the filter caps, nothing else, so that means it can't be anything different. So a short must go over the IC or over a cap, or maybe over a short inside our PCB layer. Okay, so now we have to think about how we can proceed, because it is difficult to find here the defective component, because it does not show up, so everything looks fine, and I have double checked here our IC, and you can believe me, everything is fine, and there is definitely no short here on our pins. So that is just fine, no problem. So how can we proceed? Very easy. I will now wire here up a little test wire, and then we can supply here our IC area with 5 volt, because that is the needed voltage. And you may remember when we swapped here our DDS IC, you may remember that this IC was shorted as well, and it was getting very hot, so I was almost not able to touch here the IC without burning my finger. So that is always a very good indication if the component is getting hot, because then we know the short is the IC. Or of course we can touch here our caps, and of course we can flip it over, and we can touch the area underneath our IC if we can feel something down there. So that is now our next step, and therefore let me connect here a little wire to this solder point here, And yeah, let's go ahead and see what's going on here. Okay, so here my little test wire is sorted here down to the PCB, and of course if I touch it now we have our short. So now we really can go ahead. But maybe first you want to observe together with me all here our solder pins where we have soldered in here our new IC, and you see, like me I believe, yeah, sometimes we have here some reflections, but that is, I have tested it, that is flux which is still down on the board. Even I have cleaned it a lot, but you really can see that there is definitely no short here on our pins. So really everything is simply just fine without any problem. Yeah, I've adjusted here my power supply to 4 volt, and let's start with 100 milliamps. And yeah, here you see I have connected here my power supply to the board, and I just wanna feel if there is a hot spot. And yeah, maybe we can identify what we have, and therefore, of course, oops, I have to switch on here our power supply. Yeah, and what you see is here our voltage is breaking down, and you see our power supply is in constant current. I've already here my finger on the IC, and it is drawing 100 milliamps. And yeah, so I'm trying to find a hot spot, trying to touch here all the little caps around. The IC is cold, but I see it is still drawing 100 milliamps. Let me touch here the other side of the board. Also, we have seen on our schematic that there are no components which are involved. No, it's totally cold, nothing at all, nothing, really nothing. Okay, let me switch it off here, and now let's go up to 5 volt, because that is the voltage where I can't damage anything, because this supply line is 5 volt, and I would not destroy anything in line which is not already faulty. So therefore 5 volt is fine, but additional to that I increase it here to 500 milliamps, and let me switch it on. And you see 500 milli, and our supply voltage is collapsing, and yeah, that is really odd. It is cold. It is definitely cold. So even with 500 milliamps, and so normally, if the IC would have a short, definitely it would get hot. So you really wouldn't be able to touch it, but everything is cold. The caps and the IC, and it is as cold as you can think. Okay, so now it doesn't matter. No, 5 volt is just fine. So I do not want to change the voltage, but what I want to change is the power through our fault. And once again, so it only can be the IC, a cap, or a short in a layer of the board, nothing else. So let's go for 1.5 amp, so that is enormous. So that is definitely too much. Okay, voltage is collapsing once again, and the PCB here is drawing 1.5 amps. And believe me, it is completely cold. It is completely cold. I can't feel anything. So where is our 1.5 here? No fake. Where is our 1.5 amps going through? I mean, if it would go through the IC, it needs to get hot, but it is cold, believe me. Okay, and that might be a good use for our FLIR. So let me once again here switch on, and you see voltage is collapsing, and it is drawing here 1.5 amps. And let me go over here to our circuit. So let me check that you can see it best. So I try to reduce all reflections here in the lab, which is not completely easy, but I try. It is difficult to have no artifacts here, but maybe you see there is nothing. So here and there a little artifact, but basically here is nothing. Here is, you can see my finger, of course, but apart from that, also we still drawing 1.5 amps. So the IC is not getting hot, the caps are not getting hot. If I go down here with my finger, you see that is of course an hot spot, right? If I take my finger away, so you see rest of the temperature of my finger, but it is vanishing after a short while, and that you see that I'm not somehow telling here you something which is not happening. You see voltage is still collapsed, and we are drawing still 1.5 amps, which is incredible much. And again, when I go down here to our board, and I hope you can see it here, and I need to get all the artifacts out of here, but you see nothing, no temperature difference. No, that is an artifact, so that is not real. Yeah, that is not real. So let me flip the board over. I do not want to swap. Yeah, nothing. Again, my finger, and you see here underneath here is our IC. So there is definitely no hot spot nowhere, really. It is definitely no hot spot. I hope you have seen it here. I didn't check here if it was in the field of view. Sorry for that. Let me see. So when all the artifacts are gone, so you see this area here is underneath our IC, and yeah, again, artifacts. This is not an hotspot. No, definitely nothing at all. It is cold. Trust me, it is absolutely cold, and still drawing 1.5 amps. Okay, conclusion. So I'm sure that the short is not going over or through the IC and not going through one of our caps around our IC. So that means the current, and you have seen 1.5 amps is really a lot, must go over a short which is inside the layer of our PCB. So there is no other way. If it would really be a problem with the IC, believe me, it really would get so hot that you can't touch it any longer. So that is sure. And so the only conclusion is that we really have a problem inside the board. So there is a short inside the layer. How can that happen? I mean, that is always the risk you have. From time to time it really happens that something happens inside all the layers, and so it is obviously here. The root cause is definitely hard to tell. I mean, we know right from the beginning that something happened here to our board, and we still see here that these resistors are not soldered in very professionally. So that is what we found right at the beginning. And I still believe that for any reason a too high voltage has given here to this supply line. So that was, from my point of view, the reason why our both ICs died, and why here our little filter coils were open. So this one were open, and the one which was in here were high resistance. So that tells a story that somehow the voltage must have been too high. So whatever the first tech shop did here to the radio must have been something wrong. We don't know. So maybe that was already the first step to our problem. And then of course we never should forget, when we heat a board with hot air, we always have the risk that something goes bad. And you know that I always heat the board very, very slowly, and I really try to get the temperature up, and not only in this spot. I try to get it widely over the board to get the temperature up, that we do not have a chock inside here our PCB. So but from time to time also our hot air can cause that, and therefore we will not finally know why it happens, but what we can say, now is that we are really at the end of this story and the end of this board, because this board is dead, and with a short inside the layer we are not able to do anything. It is simply dead. So the only way to get the radio working again would mean to put in a complete new PLL board, but I would not suggest that. I really would say this is an old radio, and we really did a lot to the radio, and well, something we get right, but now we are at a point where we can't go ahead with this board. But to invest in a new board is, from my point of view, definitely the wrong way, because the radio is too old, and you never know what will be tomorrow. And you know that I was already not so happy with the decision, because I know that it happens. If it would have been a brand new radio, then it is a totally different story, because then you can say, okay, it is worth to buy a new complete PLL board and put it in. But with the old radio, to invest again now into a complete new board doesn't make any sense. So therefore we are definitely at the end here of this story. I hope you learned a bit. I mean, it is a sad ending, because we can't help. That's it, and we have to stop. But anyways, I hope you learned something, and yeah, I always wish you successful repairs, but we have to say sometimes we can't help, and that is now what we have here. Thanks for watching. If you like the video, please give me a big thumb up, and catch you next time. Bye.